Okay, 10th graders, here are your last video of reviewing the aldehyde and ketone practice test questions. So at this point, we are on number 3, D, E, F, and G, and number 4, D, E, F, and G, and that will be in this video. If you have not reviewed the other videos, please go back and review them, especially if you're still kind of lost. So in this case, I am going to quickly review, describe what observations would be expected from a failings test for letter D, and letter D for what observations would be expected for number 4 on this one. So this is a propanone, and this is a butanol. So this next question, I'm kind of doing a little bit backwards as I did before. I meant to check off when I am done, but this would be your answer for number 3D. This is a ketone. See the reading about ketones. That is the properties of aldehydes and ketones that I handed out to you with this really small font, but I have also linked it on the website. So the main thing that you need to make sure that you include is that it will not form a dark red precipitate. And number 4D, same idea. It is an aldehyde. Please see that reading and review that. That's linked on the website as well. So again, the main thing it will form a dark red brownish precipitate for butanol. Moving on then at this point to letter E, draw how a nucleophile copper 1 oxide in this case would interact with the molecule. So I will do that for both cases, for the propane 2-one and then for the butanol. So that is going to be number 4E and letter number 3E. So 3E in this case this is how I would draw it. So here we have the negatively charged molecule, which is that nucleophile. I already reviewed what a nucleophile is on the video 2 for number 1 and number 2E. So you can go back to the second video to see that more about what the nucleophile is. So in this case, because of this really strong bond between these carbons here, there's not going to be any oxidation. There's not going to be a reaction that is going to produce where we have a red precipitate coming out of this reaction. In this case, number 4E, you would then see something like this. This is not the most beautiful drawing. Try to squeeze it in there. Please notice how I organize this. I encourage you to do the same, or if you have not already, to do some more practice. So here we have this negatively charged nucleophile being attracted to this nucleus of this carbon. Through that, because there is essentially a little attack coming in here from this carbon to oxide, breaking off this bond between the carbon and the hydrogen is going to be significantly weaker than the bonds between the two carbons. So this is what we'd end up with. We end up with a lot more going on there are other ions floating in our products, but the main product that we're going to end up making in this case is going to be an oxidized aldehyde. But just by looking at it, you can maybe even check out that this oxygen is added in here. This is now a carboxylic acid, remembering that whenever you oxidize an aldehyde, you end up making a carboxylic acid, in this case under acidic conditions. Moving on, so that was letter E, so letter 3E, and that was number 4E. So 3E and 4E are now complete, almost done. So here is the last couple questions I'm going to do in all at once. So 3F and 4F and 3G and 4G. Both of these ask, can this molecule be oxidized with the valence test? And G, same question. Under acidic conditions, the product formed from the valence test with the molecule can be used for esterification. So if it is true, what would be the name for the product? So I'm going to answer all of these in the last little bit. So for propane 2-one in the very beginning, no, it cannot be oxidized. It is a ketone, so therefore will not be oxidized. And for this one, yes, it will be oxidized. So in this case, true or false for propane 2-one, it would be false. That's all you would need to write. But in this case, for butanol, because it can be oxidized, it would be true, and the name for the molecule would then be butanoic acid. Looking back at this was butanol, and now it is butanoic acid. Remembering that a carboxylic acid is formed when you oxidize an aldehyde. So that is number 3F, 3G, that is 4F, 4G. If you have further questions on any of this, please, please, please email me. And I hope you all are having a restful and healthy time at home. And we will schedule some time to discuss this further. Okay, take care and have a fabulous